You're given some pieces of information that allow you to write the equation of a hyperbola in standard form, which is something that looks like this, where the center is at HK. A is the distance from the center to a vertex, and the center is the midpoint of a segment connecting the vertices. Okay, we'll talk about B in a minute. And asymptotes that we're talking about pass through the center, have a slope B over A or the opposite of B over A. So let's just go to Desmos and see what's happening here. Here I graphed technically saying that these points are the endpoints of the transverse axis is not accurate because the transverse axis is a line passing through the foci and the vertices in the center. So if I actually enable the line y equals 5, there's the transverse axis. So 1 and 5 and 7 and 5 are the vertices of the hyperbola. That means the center is at 4, 5, the midpoint of 1, 5, 7, 5. Okay. Now, when I'm given the slope of an asymptote and I can figure out the center, it's usually just easiest to figure out the equation of each asymptote. There's one of them because the slope is 4/3 and the point that it passes through is 4, 5. So you could use point slope to arrive at that. And g of x, there's the other asymptote. Now what we would like to do is kind of picture the rectangle that's created by, well, here's the points, okay? So if you find 1 f of 1, you'll get this point right down here. And if you find 1 g of 1, you'll get this point up here. Here's what they look like, okay? And if I actually start connecting them, you can see the little rectangle that's created, okay? And A is the distance from the center to one of the vertices. So from 4, 5 to 7, 5 is 3. So in our case, A is 9, or A is 3. Okay, we'll want A squared in our formula. So A is 3, B is the distance. You can think of it as a vertex to the conjugate axis. Not really what I want to say. Well, it's this distance right here from 1, 5 to 1, 9, or from 1, 5 to 1, 1. So B is 4 because from 5 to 9 is 4. And there's your hyperbola right there. I get x gets closer and closer, or larger and larger, closer and closer to infinity. Hyperbola gets closer and closer to its asymptotes. And here it is written in terms of A, B, H, and K. Same graph. Okay, there you go. I'm going to stop sharing. If you have any questions, post a comment.